Today I want to talk about classes. So in this world, we have different objects like wood, metal, fabric, plastic. We could represent different objects in the world using classes. We say when we put some variables and some functions together, we create an object. Program is made of items like variables, functions. When we talk about objects, we're talking about an entity that has both variables and functions. Some examples of objects in this word can be like a couch. A couch has some attributes like wood, like green fabric. On the couch, you can sit, you can lie down. The chair is another object, for example. It has green fabric, it has wood. These are what we call them attributes, and these are the functions. So we can say the word consists of items like wood, metal, fabric. People think in terms of higher level objects like chairs, couches, and drawers. So we can say for a drawer, operations are to put in, to take. Every object in this word, it can be represented with some attributes and with some functions. There are some particular activities here I want you guys to finish. We have abstraction and information hiding. Abstraction means when you pay attention to general characteristics of something, when you hide the details. Another name for abstraction, like when we create a class, when you have some private attributes inside a class, you have a shift abstraction. We also call information hiding or encapsulation. When we talk about information hiding means when you're hiding some information, when you're hiding the details. For example, an oven supports an abstraction of a food compartment with a knob to control heat. An oven user needs not to interact with internal pulse of an oven. This oven is an example of like an abstract data type. Objects strongly support abstractions, hiding entire groups of functions and variables, exposing only certain functions to a user. When we talk about abstraction, it means when you hide the details. When you create a class and then you have some attributes that are hidden inside the class, you have achieved abstraction. We have an abstract data type ADT, which is a data type whose creation and update are constrained to specific well-defined operations. So we call that abstract data type or ADT. We can say abstraction simplifies our word. An oven is viewed as having a compartment for food and a knob that can be turned on, heat or food. When you have an oven and you want to use it, you can turn it on, you can turn it off. You can cook something with the oven. People need not to be concerned with internal working of an oven. People don't reach inside trying to adjust the flame. An object has operations that user can apply. The object's internal data and possibility other operations are hidden from user. So, for example, when we say oven is an example of an abstract data type. Abstract data is a data type that is abstract. It means there are some hidden information inside it. When we talk about abstraction, means when you pay attention to general characteristics of something, when you hide the details. In C++, you can use a class. So we say, in order to define a class in C++, you say class, you put the name of the class. You open a brace and you close a brace, you put a semicolon. In the public area, you put the name of the functions. In this example, you have a class restaurant. It has a public set name, public set rating, and public print. I'll talk more about this public, but this class has these functions. The return type for the set name, set rating, and print are void. The set name takes a string, which is the restaurant name. The set rating takes an integer, which is the user rating. So if you say restaurant, favorite place, you're creating an object of this class. So when you say favorite place dot set name, Central Delhi, you're setting the name for this favorite place. So it's an object of restaurant. When you say favorite place, let's set rating 4. You're setting the rating for this restaurant, which becomes 4. When you say favorite place dot print, you're printing that object. It will print central daily dash dash 4. So in order to define a class in C++, we say class. This class is a keyword. You put the name of the class, you open a brace, you close a brace, you put a semicolon, you put all the public member functions inside it. If you want to use a class, you will create an object of the class. In this example here, we say restaurant favorite lunch place. I'm creating an instance of restaurant. We call this instantiating. When you say restaurant favorite dinner place, I'm creating another instance of the restaurant. When I say favorite lunch place dot set name central daily, I'm setting the name for this object. When I say favorite lunch dot set rating 4, I'm setting the rating for this restaurant. With the set name and set rating, I'm setting the name and the rating of that object. When I call the print function, it will print central daily 4, Friends Cafe 5. I'm creating 2 different objects of this class. And I'm setting the name and the rating for those 2 objects. With the print function, I'm printing them. The print function has to be defined. C++, a string type is a class. For example, when you use the string, when you say string and you put something after that, that is a class. The string class stores the string's characters in memory, along with variable indicating the length and other things. But the strings user need not to know such details. When you say string something, you're creating an instance of that class. We have some string public member functions like char at, like size t, and pushback. These functions, they work on strings. Char at returns a reference to the character and position in the string. This size t length function returns the number of characters in the string. The pushback function takes the character C, appends character C to the string's end, which will increase the length by 1. When you define a class, how can we define a class? We say class, we put the name of the class. So in addition to public member functions, the class definition has private data members. When you make something private, something happens. It means you're hiding some information. Variables that member functions can access, but the user cannot. This is the difference between public and private. When you make something private, only the member functions of the class, they can access it. When you make something public, anybody can access it. Private data members appear after the word private in class definition. In this example here, we have a class of restaurant. I have some public member functions like set name, set rating, and print. So in this class, I have a class of restaurant. This class of restaurant has some public member functions like set name, set rating, and print. It has some private attributes like name and rating. You can see that the set name sets the restaurant name. The set rating will set the rating, which is between 1 to 5. The print prints name and rating on the line. We have 2 different attributes which are private. A class definition has private data members for storing local data. We say a class user cannot access a class private data members, but the class member functions class. This is a definition of the private attribute. When you make something private, only member functions of the class they can access. In this example, set name, set rating, and print, they are member functions of the class. So they could access these private attributes of the class. When you want to define a class, public member functions, we put them in the public area. In this example, you see that we have a class, my class. It has a public FCT1. It has a private num_a. We have a void, my class FCT1, which is defining this public function inside the class. You can see if you want to define a public member of a class, when you want to define a function of the class, you put the name of the class, you put colon, you put the name of the function, and then you can initialize the variable num_a. In this example, this function belongs to this class. We say it's a member function of the class. When you want to define a member function of the class, you put the name of the class, you put the scope resolution operator, you put the name of the function, and you define it. If you just say void fct1 open close parenthesis, this is wrong. Because you need to specify what class does this function belong to, which is the name of the class. This is a complete class definition and use of that class. In this example, we have a class restaurant. We have some public member functions. We have two private attributes, which are name and rating. In order to define this set name, we say restaurant colon set name string restaurant name. It means this set name is a member function of this class. You put the name of the class, you put colon. We call this colon scope resolution operator. And then you put the name of the function, which is a set name. It takes a string restaurant name. It will put the restaurant name inside name. It's a set. If you look at the set rating, it takes a user rating, which is an integer. It will put the user rating inside the rating. It will set the rating. If you look at the print function, it's printing name and rating, and it's printing dash between them. When you say restaurant favorite launch place, you're creating an instance of restaurant. When you say restaurant favorite dinner place, you're creating another instance of restaurant. With set name and set rating, you can set the name and set the rating of the object favorite launch place. With set name and set rating, you can set the name of the rating of the other object. With the print function, you print them. It will print Central Daily 4 and Friends Coffee 5. We have two different objects of the class. One of them is Central Daily. One of them is the Friends Coffee. One of them is favorite lunch place, which the name for that is Central Daily. The other one is the Friends favorite dinner place, which the name for that is Friends Coffee. This is how we can create instance of a class, and then how we can create setters and getters, and then setters and call them. I'll talk about getters later. There are some activities in your Zybook I want you guys to finish. There's an example of a Warner info class, which explains this is a class that allows a user to set the time run and distance run and get the runner's speed. So I want you guys to finish these activities. When you define a class, you can have inline member functions. Inline member functions means when you define a member function of the class inside the class. So in this example, we have a class, my class. It has a public FCT1. It has a private num_a. We say my class colon FCT1, num_a becomes 0. If you define these functions inside the class, we call it inline member function. So a member function's definition normally appears as separate from class definition, associated with a class using colon. You could define a member function of the class outside of the class. You could also define the member function of the class inside the class, which we call it inline member function definition. So there's a class with two inline member functions. This is a class of restaurant. It has a set name and set rating. Then the set name will put the restaurant name in the name. Set rating will put the rating in the rating. The user rating and the rating. It has two private attributes, name and rating. The print function prints name and rating. The restaurant favorite launch place will create an instance of restaurant. Restaurant favorite dinner place will create another instance of restaurant. When you say favorite lunch place, that's set name Central Daily. You're setting the name for favorite lunch place. When you say favorite lunch place, that's set rating for. You're setting the rating for this favorite lunch place. With set name and set rating, you can set the name and the rating for the other objects. With the print function, you can print. There are some activities and challenge activities I want you guys to finish. We have mutators and accessors. We say a mutator function will modify or mutate a class data members. An accessor function accesses data members but does not modify a class data members. We also call them setters and getters. So in this example, we have a class of restaurant. We have a set name. This is a setter. So when I talk about setters, it means they will set the attribute of a class, which is kind of a mutator. Mutator and setter, there are different names. When I say getter, it means I'm getting the attribute of the class, which we also call them accessors. It means they don't modify the attributes, they just get them. In this example, we have a class of restaurant. We have set name, set rating. We have get name, get rating, and print. This set name takes a string of a restaurant name. The set rating will take an integer user rating. The get name will return the name. The get rating will return the rating. The print will print. When you have a getter, you put const here, and const here, and const here. Because the getters, they're just getting the attributes. They're not changing the attributes. So we can put a const here. It means it's a constant function. But this is a constant member function of the class. When you have a setter, you just define it. When you have a setter, the return type is void. When you have a getter, there is a return type, like string or int or void. We have two different private attributes, name and rating. The name is string and rating is integer. We say the set name takes a string and puts the string inside name. The set rating takes an integer, puts that integer inside the rating. The get name will return the name, which the name is a string. This get rating will return the rating, which rating is an integer. The print function will print name and rating. When I say restaurant, my place, I'm creating an instance of the restaurant. When I say my place, that's set name Maria's Diner. I'm setting the name for my place. When I say make my place set rating 5, I'm setting the rating for my place. With get name and get rating, I can get the name and rating for these objects. It says Maria Diner is rated 5. We could have private helper functions. We say a program really commonly creates private functions known as private helper functions to help public functions carry out tasks. In this example, we have a class by class. This class has a public fct1. It has two private attributes, num A and fctx. When I want to define the fct1, I say num A is equal to fctx. This fctx is a private function of the class. We call them auxiliary functions or helper functions that they help the function carry out some task. When I need to define the fctx, I can say my class some object dot fct1. That's okay. If I say some object dot fctx, that's an error. You couldn't call a private member function of the class. You could call public member functions of the class. You're not allowed to call the private member functions of the class out of the class. The private members of the function, the private member function of the class, they could be called from another public member function of the class or private member function of the class. We call them auxiliary functions or helper functions. We could have initialization and constructor. In this example, we have a class of restaurant. We have the set name, set rating, and print. This set name will take a restaurant name. Set rating will take the user rating. In the private area, I say name. is equal to no name. Rating. In this example here, we have a class restaurant. The class restaurant has set name, set rating, and print functions. We have two different private attributes, name and rating. By default, name becomes no name and the rating becomes -1. So this is what we call it member initialization, which was introduced in C++11. When you do this, we could initialize these variables by default to no name and -1. We have the set name and the set rating. The set name will put the restaurant name in the name. Set rating will put the user rating in the rating. The print function will print the name and the rating. When you say favorite restaurant, favorite launch place, you're creating an instance of the restaurant. With favorite launch place dot print, I can print the function. I can call the print function. When I define the print function, I say it's printing name and rating. I say restaurant favorite launch place. I call the print function. It will print no name and -1. You can see by default, the name becomes no name and rating becomes -1. When I say favorite launch place dot set name and set rating, I can change the name and the rating. When I say dot print, it will print central daily and forth. So I'm creating an object of the class. I'm initializing the name and the rating. Then I'm using the set name and set rating to change the name and the rating and then display them. You could also use a constructor. C++ has a special member function called constructor, which is called when a variable of a class type is declared, which can initialize data members. A constructor without argument is what we call a default constructor. In this example, this class has a constructor that doesn't take any arguments. It has a set name, set rating, a print function. It has name and rating. This constructor, which we call a default constructor, will initialize the name to no name and the rating to -1. So when you want to define the set name, you put the restaurant name and the name. For the set rating, you put the user rating and the rating. The print function will print the name and the rating. When you say restaurant favorite launch place, you're creating an instance of this restaurant. With dot print, you can print the attribute, which is no name and -1. When you use this as set name and set rating, you can change the name and the rating. With the print function, you can print central daily form. You can see that we could use a constructor to initialize variables of a class. So what does the constructor do? The constructor would initialize the name and the rating to no name and -1. Default constructor is a constructor that takes no arguments, or if it does take any arguments, they all have default values. There's an example in your zybook which discusses classes and vector of classes. In this example, we have a class review. This class has a public set rating and comment, which takes a rating and a comment. It puts the REV rating inside the rating. REV comment goes in the comment. It has a get rating that returns the rating. It has get comment that returns the comment. The private attributes of this class are rating and comment. By default, rating becomes -1 and comment becomes no comment. When you say vector review list, you're defining a vector of type review, and the name of that vector is review list. When you say review, current review, you're creating an object of this review class. I have integer current rating, string current comment, unsigned int I. I ask the user to type rating plus comments. The user puts the current rating. I save it in the current rating. I say while current rating is greater or equal to 0, I get a string here. I say current review, does set rating and comment, use a current rating and current comment. In this example, we're creating a vector of class, and then we're filling it with data using pushback. Whenever you say pushback, you can push one item inside your vector, and then you get the rating and you push another one and you keep filling it. If you want to output those, you can say for I equal to 0, I list and review list dot size, which the size function tells you how many items you have inside your vector. You get the review list at I, you put it in the current review. You say if the current rating is equal to current review dot get rating, see out current review dot get comment. This code here is going inside your vector. It's checking the ratings for each element inside the vector. If it's equal to that current rating, it will get the comment and it will display it. This is the output for the program. If you put 5, it says great place, love food. 1, 4, new owners are nice, what a gem. -1, it stops. This is an example of how you can create vectors of classes. There's another example in your zybook that shows a class with a vector, which is the reviews class. In this example, you have a class review. You have a public set rating and comment, which takes rating and comment. It puts the rating inside the rating, comment inside comment. You have the get rating that returns rating, get comment that returns comment. The rating and comment by default, they become -1 and no comment. We have a class reviews that has public member functions like input reviews, print comments for ratings. It has integer get average rating, which is a constant member function of the class. So in this example, we have a class reviews. It has some public member functions. It has a private review list, which the review list is a vector of classes. It means inside this class, we have a vector of classes. This is the definition of input reviews for reviews. If you look at the reviews, input reviews is a member function of the class. So definition of this function says review current review. There is some definition here I want you guys to study. This is the definition of the print comments for rating. So this is a definition of the get average rating. In the main function, I say reviews all reviews. I create an instance of reviews. I say string current name. I create a string. I have int current rating. I say all reviews dot input reviews. I'm calling the input reviews from all reviews. So this is how we can create an instance of the class, and then how can we put inside a class a vector of classes? So I want you guys to study these examples and finish these activities. You could use reviews in restaurant class. In this example, we have a class of restaurant. This class has some public member functions. It has 2 private attributes, name and reviews. You can see that the name is a string and reviews is an instance of reviews. This class has read all reviews. It has print comments by rating. When you say restaurant or place, you're creating an instance of restaurant. String current name, you're creating a string. I can get the name of the restaurant. I can pass it to the set name to set the name of the restaurant. I can call all read all reviews functions. So this is the output. It shows how it works. But when you want to define a class, you put the name of the class and then you define it. The class can have some public member functions. It could have some private attributes. So I want you guys to finish these activities. You could have separate files for classes. You can have 2 files per class. Programmer typically puts all of the code for a class into 2 files, separate one for another. If one of them is the class name.h, the other one is the class name.cpp. In the class name.h, it contains the class definition, data members, and member functions declarations. In the class name CPP, it contains member functions definition. In this example here, you can see this is the header file. We're defining the class with public member functions. It has a private attribute. In the CPP file, we include the store item.h, which is this header file. We define set, wait, answers, and print function. You can see in the CPP file, we define the member functions of the class, which in this example, we have two different member functions, print and set, wait, ounces. In the main CPP file, we can include the store item.h, which is the header file. We say store item, item 1. We create an instance of this class. Item 1.set weight answers 16. I'm calling the setter. For weight ounces, I'm passing 16 there. Item 1.print, I'm calling the print function. It will print weight, ounces, and 16. It's a very good practice to separate the files when you create a class. You could create a header file and a header file. You could create a CPP file. The CPP file will have the definition for those functions and the header file. I want you guys to look at these examples. There's an example here that shows the restaurant review classes. You have a class of review, and then these are the definition for your functions. So you have the review header file, which has the function headers for your class. You have this reviews a CPP file. It has all the definitions for those functions and the header file. We have restaurants.h file, which it has the header files for the functions. If you look at the restaurant.cpp file, it has a definition for those functions inside the header file. When you want to choose what classes to create, you need to look at things inside your program. You will look to see what important things you have inside your program, and then you could create class for them. When you create a class, the classes, they have some attributes, they have some functions. If those attributes, which are usually private, you have something private, you put minus. If they're public, you put plus. This is the UML diagram for classes, which it has the name of the class. It has private attributes and public member function of the class. You could represent classes with a rectangle, which at top of the rectangle, you put the name of the class, you put the attributes there, and you put the functions there. There are some examples in this chapter I want you guys to finish. Section 7.10 talks about unit testing and test benches. I want you guys to study this chapter. Finish all the activities here.